Students, we start Unit 6, conic sections today, by taking a look at parabolas. Specifically, we're going to be working with horizontal parabolas, so just inverted regular parabolas. We're going to go over a lot of stuff, but ultimately it comes down to two learning targets. Number one, graphing horizontal parabolas, and then learning target two, writing equations for horizontal parabolas. So you'll be given some information or a graph, and you'll have to use that in order to write the equation. So ultimately, two kind of pretty simple things, but we've got a lot of concepts that lead up to this. So taking a look at conic sections, the book had an image here, and I don't think I could do any better than what we've got here. So when we look at conic sections, or cones, and then we take a section out of it, so just a cross section, we cut through a certain type or part of the cone, hence the name conic sections, we get different shapes. And so throughout this unit, we're going to be looking at the variety of conic sections that we might have. And so if we take an angled cut through here, you can see that we would wind up with an ellipse. If we had a horizontal cross section, you'd see that we'd wind up with a circle. You can see that if we take a different kind of angled hit through here, you wind up with a parabola. And I can imagine that you could see maybe just doing a different angle, and you'd wind up with a different type of parabola, like a horizontal or a vertical parabola, like you might here. So if you kind of like went upwards, you could wind up with a different type of parabola. Or you can even see here, taking a cross section all the way through, you wind up with kind of what looks like two parabolas almost, just kind of running away from each other. And those are called hyperbolas. So these are the four different conic sections. We've already talked about circles this year, and so we'll be focusing on today parabolas, and then ellipses, and then hyperbolas to finish up. So ultimately, we've got a lot of vocabulary here, and so here we go. First of all, what is a parabola? And we already know what a parabola looks like. You know, if I were to graph a parabola, you would remember what that looked like from when we were doing quadratic equations. The graph of a quadratic equation is a parabola. But we can also define it in a little more technical term. We can say a parabola is the set of points equidistant from one point and one line. Right? And so it kind of works like this. If I have a parabola, what you'll notice is each of these points would be equidistant from, well, not one point, because you can see, it's a certain distance here, be a different distance here, be a different distance here, and so forth. But it's not equidistant from this one point, but it's equidistant from a point and a line. And so, this distance from here to here is equidistant. And the distance from here to here would be equidistant. The distance from here to here would be equidistant. And so that is really what a parabola is. It's equidistant from a fixed point and a fixed line. And so going back to some more of the vocabulary here, okay, the focus is this fixed point, like this one right here. This would be the focus. And the directrix would be the fixed line. So this would be the directrix. And so this parabola is always going to be equidistant from the focus and the directrix. All right, so we have two kinds of parabolas. We could do horizontal and vertical parabolas. So vertical parabolas have a vertical axis of symmetry. Remember, this is called the axis of symmetry. Okay, and so this would be traditional, what you would normally see. And you can see it has a vertical axis of symmetry. But then, of course, we can kind of go the other direction. We can go this way. This would also be a parabola. This is a horizontal parabola because the axis of symmetry is horizontal. And these have equations. We already know vertical parabolas. We know that there's the equation y equals ax squared plus bx plus c. We already have this one down. We also know vertex form. Y minus k equals a times x minus h squared. So we have this formula. We're going to learn a couple of new ones today. So this new one, simply put, when you have a vertical parabola, it's going to be y squared equals 4 times p times x. And for both of these, p is going to equal the distance from the focus, so distance from the focus to the directrix. Okay, so this distance right here would be p. So I'll keep that in mind. This will be a new formula for you to have down. Of course, if there's a shift, we could use it just like we do here. So we could say y minus k squared plus 4 times p and then x minus h. So that's potentially another one that you would want to use if there was a shift. All right, and then with horizontal parabolas, it would just be the inverse of this. And so we would have x squared equals 4py. And again, we'd have x minus h squared plus 4p, and then y minus k. So these are the inverses, and you can see you just switch the x and y like you do on an inverse function. All right, so let's get down to it. What's this going to look like? Well, learning target number 1 is graph, and then give the domain and range. So here, we actually just have something that it looks like it's in that standard form that we knew from before, except that it's been flipped. It's the inverse, and so I know that it's going to be a horizontal parabola. I know, again, it's going to be the opposite of the sign, so I've got y minus 2, that means it's going to go up 2, and then x plus 3 means it's going to go to the left 3. That's what my vertex would be. There's no a value here, and so it's just going to be that regular parabola, kind of over 1, up 1, except that, I'm going to be going sideways, so like over here, and then over 2, up 4, and there we've got it. Here is our horizontal parabola that's been graphed. You can see that it would be, just the same thing. If I switch the x and the y, you'd kind of go over and it'd be reflected over that line y equals x. Give the domain and range. Well, domain, you can see that this is going to be all real numbers. X is got to be greater than or equal to -3. And then range, well, this is just going to be all real numbers. You can see that it's going to go up forever this way and down forever that way. All right, next one. Similar, at least not at first, but here's what we're going to do. We're going to go ahead and complete the square so that I can get this into its proper form. So we're going to go ahead and push this 5 over onto the other side. And that'll leave us with x minus 5 is equal to 2, y squared plus 6y. Remember that before we complete the square, we need to get this a value out of here. So we're going to factor out a 2 from each of these. We're going to wind up with y squared plus 3y. Over here we've got x minus 5. Now if we're going to complete the square, remember that we're going to take half of b, 3, and square it. So half of 3 would be 3 halves, and then I square that, that would be 9/4. But of course, what I added to the right side wasn't actually 9/4 in total, it was 2 times 9/4, which would simply be 9 halves. So if I added 9 halves to the right, well then I would have to add 9 halves, or 4.5, to the left. On the right-hand side, now I have a perfect square trinomial. It looks a little awkward, but remember, it's just going to be half of this, or the square root of this, and so I've got y plus 3 halves, half of 3, squared. And then on the left-hand side, I've got negative 5 plus 4.5. That would wind up being minus 1/2, so x minus 1/2. And now I've got it back into this form, the vertex form, but of course, you know, the x and the y have been flipped, and so that means it's been inverted. I've got a horizontal parabola with a shift. And so I've got y is plus 3 halves, or 1.5, so I'm going to go down 1.5. Then over here I've got minus 1/2, so that means 1/2 to the right. So down 1.5 to the right 1/2. There's my vertex, and this time I have an a value of 2. And so if I go over 1, I'm going to go up 1, 2. If I went over 2, I'd go up 8. That should be over there. And so ultimately this is about what it looks like. All right, so that's graphing some parabolas. But what about some examples where we don't necessarily have a full formula? What we have here is just kind of this other one, the one that we introduced, where we had x squared plus 4py, or y squared equals 4px. Well, here we've got x squared, which means that this is actually a vertical parabola. If I wanted to think of it another way, I could just divide both sides by 8, and I'd have y equals 1/8 x squared, which is a little more traditional, but you can see why it would be a vertical parabola. It's in that regular form. But ultimately, let's take a look at the rest of this stuff. Find the focus, the directrix, the vertex, and the axis of symmetry of the parabola, and then graph it. Well, here's the deal. If I've got x squared equals 8y, well, the general form here is x squared equals 4 times p times y. So it's kind of like this 8 is the 4p. So I've got 8 equals 4p, which means p is equal to 2. And what does that mean? How does this help me if p equals 2? Well, p is the distance from the vertex to the focus. And so you can see here, you can tell that when x equals 0, y equals 0. And so the vertex is at the origin. So vertex, say, is at 0, 0. Part of a list of things over here. And so the distance from the vertex to the focus is 2. And so knowing that this is the axis of symmetry is the y-axis. So let's write that down. Axis of symmetry is x equals 0, the y-intercept or y-axis. It's 2 away, and so it's going to be up 2. So let's say the focus is at 0, 2. All right, we've got lots of this stuff now. We've got the focus. The directrix is going to be an equal distance away here. And remember, this is your line. So your equal distance away, that's not a very good line. But you can see here it's going to be through the y-axis at -2. So the directrix is y equals negative 2. What I would do at this point is I would just pick a couple of values for either x or y that would help me plot the rest of it, knowing that it's going to kind of go like this. Sorry, through the vertex there. The number I would pick would be 2. And I would actually pick 2 for y. And here's why. Well, if I plug in 2 for y here, I get 16. So I get x squared equals 16. So that means x equals 4 and x equals negative 4. So when x equals 4, I get 2. And when x equals negative 4, I get 2. And you can see how that kind of lines up there with the focus. And boom, I get my parabola. All right, so that's that. Let's move on to another example. This will be the last one here for learning target 1. Same deal, except this time you can see that we've got a horizontal parabola. This time we've got the y squared version. And so, again, this part right here is going to be the 4p. And so that means 4p equals negative 28. It means p is equal to negative 7. And so again, knowing this is a horizontal parabola, p is negative 7, so that puts this right over here. Again, we don't have any shift, so we know that the vertex is at the origin. So again, let's start writing this stuff down. Vertex is at 0, 0. We've got the focus is at negative 7, 0, which means the directrix is going to be the line that goes through the x-axis. So that means x equals 7, right here, through the x-axis at 7. And then we're going to, let's see, what else do we need? The axis of symmetry is going to be a horizontal axis of symmetry, so y equals 0, or the x-axis. All right, so we've got all of that information here. Now, let's actually pick some values. Again, I'm going to pick some values for x this time. And again, I'm going to pick x equals negative 7. So when x equals negative 7, I wind up with, we'd say y squared equals negative 28 times negative 7. And negative 28 times negative 7 is 196. And when I take the square root of 196, I wind up with 14, positive and negative 14. So when x equals negative 7, I got positive 14. When x equals negative 7, I got negative 14. And that's going to help me graph this considerably. So I would say negative 7 for x. I got positive 14, which would be way up here somewhere. And negative 14, which would be way down here somewhere. And so we wind up with something very wide that looks something like this. All right. So there you go. That's graphing parabolas. Well, I'll call this section 1. We'll do section 2 in another video, or learning target 2.